From Photonics Media, this is All Things Photonics, a podcast where we explore industry-shaping advancements in lasers, optics, imaging, metrology, and sensing. Each episode, we'll speak with some of the brightest minds in industry and research about the trends shaping the landscape of photonics.
Today's episode is brought to you by Hamamatsu Corporation, a leading manufacturer of devices for the generation and measurement of infrared, visible, UV light, and X-rays. Hamamatsu is dedicated to the advancement of photonics through extensive research and offers specialized systems for select applications. Visit hamamatsu.com to learn more.
No matter what product you market, repeatability of performance and consistency of operation are benchmarks that cannot be compromised. End users demand from their commercial solutions proven effective products. No room is left for compromises nor shortcuts. This reality is widely understood and for a range of products, from those targeting everyday consumers to high-stakes systems operators. But at the same time, consumers of many products are seeking constant innovation. New and better and updated are requirements in today's marketplace. The need for custom solutions is another consideration that companies face. Engineering a uniquely tailored, application-specific system that retains all of the known benefits of the standard is no small feat. It is also a frequent demand in an increasingly sophisticated technology landscape. In the domain of industrial lasers, these dynamics serve as the backdrop against which major developers and manufacturers operate their businesses. The drive to innovate, the need for reliability and repeatability, and the ever-changing demands of OEMs and integrators may overlap, but they never evaporate. Aldas Juronis, CEO of leading industrial laser developer and manufacturer EKSPLA, joins us on the All Things Photonics podcast to discuss the current marketplace and EKSPLA's commitments to harness creativity for highly effective laser systems. In doing so, EKSPLA's opportunity is to drive trends just as much as it is the company's mandate to respond to them. It is an undertaking that spans research and academia, industry and OEMs, and European, North American, and Asian markets. The innovations central to our conversation are both technological and global. EKSPLA's direct refrigerant cooling solution and Lithuania's Silicon Valley InnoHub, for example, are conversation points with differing scopes, yet both have real impacts on the present and future of industrial lasing. The timing of our chat with Juronis could not be more perfect, with Laser World of Photonics just around the corner later this month. EKSPLA will be a company worth visiting for those in attendance, and for all of us, a company worth monitoring even after the show concludes. Happy Laser Munich, Aldas Juronis, CEO of EKSPLA, up next. So a point of pride for EKSPLA, for several laser firms, but really for EKSPLA, is its creativity. And that can manifest in many different ways. But as a company evolves, as a company ages, it's important, I think, and especially for EKSPLA, to make sure that that creativity is retained. At this point in the company's history, how is that reflected for customers?
Okay, it's a very good point. As innovation, you call it creativity, but actually we call it innovation is as part of the EKSPLA's DNA. So EKSPLA is already, more than 30 years old company. And since the very beginning of the company, the innovation was the key advantage, I would say. And even we just recently updated our strategic points for the further development. And as our vision, we pointed out that EKSPLA needs to be the most innovative and to work with the best. What do we mean with the best? First of all, with the best professionals. Best engineers and scientists, which we employ as our employees, and the other thing, the best customers. So we want to work, and we already work with the best universities, research institutes, and of course the best industrial customers, and the third, of course, with the best suppliers. So that's our motto, and this all this is based on the innovation. And as I mentioned, the company was established more than 30 years ago, and we started as a picosecond on the picosecond technologies. At that time was one of the most advanced technologies, and that's why the very young company from middle of nowhere, at that time Eastern Europe was middle of nowhere, But our first markets, foreign markets, was Japan. So we were recognized, first of all, in Japan, and later on we turned into the Germany, later on into the United States, and etc. And so this helped us grow. But why we grew? Because of the innovations that we were able to offer to our customers. And this innovation background was always following us. We were following the innovations, trying to constantly innovate, not just current products, but also develop new technologies based on which we are creating and developing new products. So that's why we were one of the first companies that introduced to the market the diode pumped optical parametric generator integrated into one housing to the market, for which we were recognized with the Oscar in Photonics Prism Award. That was our first recognition by the Prism Awards. And later, just recently, last year in 2024, we were recognized with the second Prism Award for our industrial femtosecond laser, completely different technology, but again, for the innovations that were implemented in that laser, starting from the direct refrigerant cooling and ending with the most flexible gigahertz burst option.
So a couple key points there that you brought up. I want to go back to something early in your answer, and that is working with and working for research institutes. And this is something that maybe is a little bit different in Europe than it is in the United States. And part of that has to do just with the national lab model versus the IMEX and LEDs in Europe. It's a little bit of a different, there's a little bit of nuance there, I should say. Is there a difference or a benefit in working with OEMs, working with research institutes, working for industry? Has that enabled the company to grow? Because those are different audiences or end users.
Absolutely. So you're absolutely right. So it's initially, since we started 30 years ago, ultra-short pulse lasers such as picosecond and even nanosecond, at that time it was more for the scientific applications, working with the research labs and the universities and institutes, because there were no enough applications at that time developed for the industry, plus the technology wasn't mature enough to be, let's say, stable and robust, so you can use in day-to-day operations for the industrial applications. So therefore, of course, we gained experience while working with the universities and institutes quite a lot. While working with the OEM, it's a different story, because there is and it took some time for us to learn the differences, because while working with the scientists, you also and having this innovation as a backbone. So we always strive to do the better. And until we realize that working with end customers is not about always doing the better, it's rather for repeating the same as you did last time, because it's about consistency, it's about reliability, it's about little deviation between the parameters between the different units. While working with scientists is always about achieving each time better, trying to push the borders of the physics in some cases even, which is not the case for the OEM customers. And of course, for OEM customers is the reliability and easy for maintenance. And so that's why while we were developing our newest OEM product, femtosecond industrial laser, Femtolux 30. So we took that into as the main cause. Okay, we're not just developing another one femtosecond laser, because it's not about getting some parameters. It's more about the user friendliness and the helping for the integrators and customers to rid of any hassle what's related with the laser maintenance. And we start thinking, okay, what's first comes to a mind about the reliability issues when you speak about the laser? And then we realized, after speaking with our customers, it's nothing related to the laser. It's about cooling. So the chillers, the component that breaks the most oftenly, not the laser itself. So then we came to a point, okay, then we need to find a solution. So that's why we came with the idea of direct refrigerant.
Let's talk about cooling, and specifically refrigerant cooling. How does it differ from conventional approaches to laser cooling? And maybe let's back up. What is cooling in the essence, in the context of working with industrial lasers?
So it's unfortunately with all the lasers, the wall plug efficiency isn't very great. So if we speak about direct pump lasers, we are speaking here about some several tenths of percentage points. What does it mean? That means that remaining energy, remaining power, we are changing from the electricity into the heat, typically, which means we have a lot of energy that needs to be somehow took away from the laser. And here there are a couple of ways how to deal with the excessive heat that is being generated during the laser, while the laser is operating. So, of course, the most simple is the passive cooling, where you can remove the heat using the simple convection. So, but of course, it's limited to a very limited amount of cooling capacity here. So the next comes to the active cooling, where you're just adding additional fans to remove some additional heat. But again, there is still a limitation of the amount of the excessive heat that you can remove. Plus, the additional drawback here is that the heat that you are removing is still remaining in the same space where the laser is located. And not always it's acceptable for the other components or other environment where the laser head itself is being located. So that's why the most often and the most common way of cooling down laser is the water chiller, where you use the water which circulates through the laser head. It's removing the heat from the laser head into the different location, typically to the chilling unit. And then the water is you can cool down the condenser using the different ways of either using refrigerant compressor to cool down the water, or to use another water cycle than you need to have in the facility, the running water. So it's but having the water, there is a lot of hassle because you need to perform maintenance for these water chillers. You need at least twice a year to change the water or other liquid that you use for cooling. You need to change particle filter, and of course there is always a risk of water leakage, which is the worst thing that could happen to any facility. So what we did, we simply rid off the water cycle at all, leaving just the refrigerant cooling agent circulating through the flexible hoses to the laser head, to the cooling plate that is attached to the laser head. And of course, in order to be able to cool down the laser in this way, the laser itself needs to be designed properly in order to avoid any thermal gradients propagating across the laser head itself, in order to avoid any deformations and etc. So, but of course, we were doing not only by ourselves, including our partner from the United States, who provided all the cooling components. But at the end of the day, we managed to perform at the first in the market industrial laser that is using that refrigerant cooling for removing the excessive heat. And actually, integrators that have started to use our lasers, they are really amazed about the friendliness of the laser, because you simply shouldn't care about any cooling at all. You put the laser, install the laser, and forget that it exists. It simple works like that. No any maintenance required.
So this really is an innovative technology, or a solution for EKSPLA, one that really offers user friendliness.
Just one of course.
Just one of many. And I think part of being an industrial laser company, and obviously you can speak to this better than I can, is that there is a need to adapt to industry trends. But at the same time, there's also this great potential to innovate, to drive industry trends, to determine industry trends. So these things are happening together in parallel, and they're happening constantly, especially as you work with science and research and OEMs and industry. I just think about cutting sources, materials processing generally, but really cutting, and that's a trend that's benefiting a company like EKSPLA. But EKSPLA is also innovating that trend. I want to talk about this dynamic, and the question though is, what does the future hold for lasers and materials processing, and particularly, I guess, femtosecond lasers?
So yeah, it's a very good question. So it's we see how the market is adopting the ultra-fast laser sources for the processing of different materials. And the beauty is here that these are still being developed. I mean, new applications for developing different materials using the femtosecond and ultra short pulse laser sources. New technologies are being developed and they are evolving each year. And the beauty here is relies with the ultra short pulse technologies, where you can using the in other sources it's called ablation to process the metals or brittle materials, transparent materials, or polymers, and to get the highest quality, highest accuracy of processing compared with other methods, especially where you can't apply any more physical tools to the very tiny parts of processing that you can, because the features that you can process with the femtosecond laser, it could lie down to the several tenths of micrometers. So it's and speaking about the future applications, not future, but the current applications where the ultra short pulse lasers are having advantages, is of course, as I mentioned, I would say that first of all it comes to the transparent and brittle materials such as glasses, sapphires, diamonds, because where processing with other tools is really complicated due to the material properties. While using the laser, you can process the very tiny features inside the glass, on the surface on the glass, not just cutting but drilling, and just recent applications that the semicon industry is looking into is the through glass via processing. So processing of around 100 microns of diameter vias in huge volumes in very low space. And of course, there are a number of processes, but most of those processes are laser assisted in one or other way. And number of companies that are trying to build the processes that would be purely related on the laser processing, not involving any chemical processing afterwards. So it's the other applications is, of course, micro processing of, let's say, different metals. First of all, it's where currently the benefiting from the femtosecond laser is stent cutting, and specifically very small stent cutting, the ones that are being used in inside the blood vessels
yes,
that comes in
the
into the
intravessel stents. Yes,
intravessel stents that comes inside the brains, because the bigger stents can be processed with other kind of lasers, but those tiny stents can be processed only with the femtosecond lasers. Medical tool marking, as black marking, polishing, applying the new technologies such as gigahertz burst. You can polish different surfaces, both metal surfaces as well as even the polymer lenses or glass surfaces. Microstructuring of the surfaces, changing its behavior from hydrophobic or hydrophilic. So forming the microstructures on the surface itself of different kind of materials, and going to a more, I would say, exotic applications such as selective surface activation induced by laser. What does it mean? After the specific activation with a laser source, typically it's ultra short laser source. Depending on the material, it could be femtosecond or picosecond. And applying of some chemical processes, you can apply on those activated areas the conductive materials such as copper, silver, or gold, or others. And this can be done on any kind of dielectric material. So be it ceramics, glass, or polymers, almost any dielectric material. So, and these are the new technologies that some companies are developing, and they are really getting very big traction in the semicon industry, in electronics industry, when you need a very tiny conductive material which allows for, let's say, to shrink the sizes of the features, let's say in semicon packaging or in electronics when you are building the really small devices.
That's a terrific answer. Number of applications, number of trends, and a number of innovative technologies. I want to talk about EKSPLA specifically, and let's talk in the period maybe since COVID, 5 years or so. What trends is the company most keen to act on, and what are the types of dialogues that you're having with customers and end users right now that maybe you weren't pre-pandemic?
So one of our primarily goals while serving our customers is, of course, the customer support. So the perfect customer support, where EKSPLA always strives to be one of the best in the market here. So, and during pandemic, so what we realized that actually it's really essential to have proper technologies in the laser that could allow remote assistance to the customers without physical visit of our technician on site. Because as you remember, no one was allowed for traveling and making assistance to the customer. Even if the customer were able to go to the lab or to perform some tasks, nobody else was allowed to travel and to make assistance if there is any maintenance is required. So, thus encourage us to develop additional features inside the laser, electronic and software, which allows for detection of the laser parameters remotely for our technician, which simply needs to connect to the laser remotely, of course, after the, getting approval from the customer side, because lasers are not constantly being connected to the network. They can be connected only when the customer is allowed to do so. So, but when the customer is giving this permission, our technician can connect to the laser, provide inspection, and to do remote, let's say, assistance, not just to customer but to the laser itself. I mean, changing some parameters and advising to the customer what can be done. And now what we see, a lot of issues that previously were or even if they were previously be resolved remotely, now it takes much lower time, which reduces the downtime for both scientific and industrial customers, and also improves the let's say user experience for the customers itself. So this is the first thing that we learned through during this pandemic period.
Lithuania has a particularly dynamic laser ecosystem, and it's really unveiled itself to the world recently. And I think about the Silicon Valley Innovation Hub or InnoHub, and other developments in the last just couple of years. Really, what has the message been in that unveiling about the dynamic capabilities of Lithuania's laser and really photonics ecosystem?
Yeah, it's quite a unique thing that in Lithuania, in such a tiny country, we have such a strong photonics community. So in such a small country of over 2 million of citizens, we have more than 60 companies in photonics industry, and it seems that it keeps growing each year because new startups are being evolving each year because it's a really growing market here. I mean, in terms of ecosystem, and what helps us the most, I would say, because we have these ecosystems locally. Now, what does it mean? We have a number of laser manufacturers that are operating, and not small ones, big ones, such as our company, such as other companies, and well known in entire world as laser manufacturers. And around those companies, we have a lot of optic suppliers, not one, but bunch of them. We have a lot of coating suppliers, so which allows us to do our development. On new products, applying different kind of optics with different kind of coatings, not in the shortest possible time, while having everything in the very close location. And the interesting fact that all those 60 companies, most of all those 60 companies are located in the same city, the capital city of Vilnius, which makes really all the communication and transportation really very fast, since the idea to the final product, to the final prototype of any kind of assembly or component is really very easy. And this helps to grow both the laser manufacturers as well as the component suppliers, in particular the optical component suppliers, as well as laser integrators who integrates our local lasers into their machines and ship all over the world. The only thing that we are missing here in Lithuania is, broadly speaking, is end users. Because of the tiny country, we do not have here no semicon users or semicon manufacturers. We do not have enough electronic manufacturers, so that's why we are forced to work all over the world with the different customers. So, but from the another perspective, of course, that encourage us to go to different markets, to go to different markets, open our branches, and to start working with local customers.
60 companies and a dinosaur, I should add, every year. I do want to ask about just the nature of the political landscape in the last 3, 4, 5 years, and what that has meant for a company of your size and in your geographic location. Has that necessitated any changes for EKSPLA, either in terms of its manufacturing practices or its customer base?
It's as we are specifically, not just EKSPLA, but all the Lithuanian ecosystem mainly are orienting to the ultra-short pulse laser market, which is a niche market. If we speak about the photonics overall, it's still a niche market. It's despite the fact that it's already being adopted by certain industries, but it's still, I would say, it's being discovered by many other industries where these ultra-short pulse laser technologies can be used in other industries. But that forces us to go everywhere in the world, looking for customers, and that's why I would say geographically we are everywhere where the lasers are being used, where the ultra-short pulse lasers can be used, both for scientific or for industrial use. So we have 4 own branches operating in United Kingdom, United States, China, and South Korea. Plus, we have more than 20 representative offices in other markets, in Asia, in Europe, elsewhere. That helps not only to sell, but also to support our lasers and to provide the best service. From another point, of course, we are constantly looking into the new markets for from the application side. And these political changes that what's happening over the past several years, I mean, geopolitical tensions and new wars that have been started here in Europe and in the Middle East. So it drives a lot of attention towards the defense market. And we already were involved in certain defense R&D projects while supplying a number of our scientific lasers to different research organizations that are working for the defense. But now specifically, we are start looking into the to get being even more involved, because we have certain qualifications, we have certain experience and knowledge to support the current defense tasks that are being resolved as of now, not only with our lasers, but also with our laser electronics. Because we are producing not just lasers, but also laser electronics, which is one of the best in the market.
I want to end, just with a topical question here. As we speak, we are on the precipice of a very big and very important, I think, industry trade show, that being Laser World of Photonics in Munich. And EKSPLA is always a presence at these events, has been since I've been in the industry and even longer. And you mentioned the Prism Awards earlier, and this is obviously tied to Photonics West. But there's a lot of notoriety and a lot of acclaim that comes with winning a Prism Award. And EKSPLA's done it multiple times for multiple different technologies. What does that mean for a company? And obviously, Laser World of Photonics, Laser Munich, has its own very robust awards program. But what can that do for a company?
As you mentioned, the Laser World of Photonics. We just, I don't know, just recently it was announced that our latest femtosecond product, Femtolux 50, was shortlisted in the industrial laser system category for the Innovation Award, and the winner would be announced during the Laser World of Photonics in Munich. So, which is also a great achievement, even to be shortlisted in this very really competitive application for the award. What does it mean? These type of awards. So first of all, I would say it's a huge benefit and motivation for entire company, for all the EKSPLA employees that are working, because it's a recognition that the technologies and the products that we are building, they are being recognized by the highest professionals on the market. But that doesn't mean that it helps itself. I mean, just getting the award itself, that doesn't mean that you would be successful. It's only a beginning of the journey, I would say, because the rest, it's a lot of hard work to further develop products itself. And in order to make a perfect product, we constantly listening to our customers, what are the main pains are, how to resolve them, how to help them to deal with those pains, how to help them resolve one or other issues. And while doing that, we are trying to do the best products for our customers. And that's actually what's making the essence why we're doing this. So any kind of awards, including the Prism Awards, it's only helping us a lot. It's very important, but it's helping to get some attention, to open the doors. But the rest, of course, need to be done by us. I've seen number of cases where the product, after getting Prism Award, it's going to nowhere, or they do not achieve enough traction or the success overall, because the award itself, it wouldn't replace your work with the customer. It wouldn't do your product the best. It's only the marking that actually it could be best product. But the rest relies on the company, how company perceives that. And we always understand that it's a huge recognition, of course, but it's also a huge responsibility, because while having the awarded with a very prestigious award, that means the expectation from our customers is also very high. So therefore, its responsibility on us is also very big to make this product work perfectly, so that customers would be very happy while using the product that was being announced with the prestigious award.
Well, Aldas Juronis from EKSPLA, our guest on the All Things Photonics podcast. Aldous, thank you so much for joining us. Have a great show in Munich. We'll see you there, and we'll talk again soon.
Thank you very much. Yeah, thank you very much.
With that, we conclude another episode of All Things Photonics. Thank you to our sponsors, to the technical staff behind the scenes, and to continued support from the Photonics Media editorial team. As always, questions, comments, thoughts, and ideas are welcome. Let us know how we're doing via email at allthings@photonics.com. All Things Photonics is available on all major platforms and on our website, photonics.com.